Well, good evening, everyone. My name is Les Smith. I'm with the Michigan Department of Environment, Great Lakes, and Energy. It is my pleasure to welcome you to this evening's MPART Pfas Regional Information Webinar for the Lansing region. Joining me in the background is Mr. Jim Ostrowski, who will be helping monitor for your questions and raised hands this evening. And it again is a pleasure that you all have taken the time to participate in this webinar today. Before we bring on our first speaker this evening, just want to go over a couple of things. Next slide. I just want to let you all know that all of our lines are muted, which means that you can hear us, but we can't hear you. And we are also recording the webinar so that in about a couple of days, you should be able to have access to the recording to rewatch and share with others. We will be making a closed caption version of the webinar available as part of that recording. Next slide. To introduce to you to some and as a refresher for others, we are using Zoom today, so I want to talk to you about how to participate during the meeting. We will have an opportunity to answer questions later after the presentations are completed, but you can still send questions throughout the presentations. There is a Q&A call-out box located at the bottom of the screen in your webinar control panel. You can type in your questions there as you see fit during the presentations. There will be an opportunity later to ask questions. You can also raise your hand. You can do an electronic hand raising by clicking the hand that is also located at the bottom of the screen. And for our listeners who are on the phone, looks like we have a couple of listeners on the phone only. In order to raise your hand electronically, you can push the star key and the number 9, and that will electronically raise your hand, and we'll see you, and we'll unmute your line so you can ask your question. With that, we will welcome to the stage, or to the podium, virtual podium that is, our first presenter, Mr. Steve Sliver. He is the Executive Director for the Michigan PFAS Action Response Team.
All right, thank you, Les. Appreciate the introduction there, and good evening, everybody. Welcome to our second of 6 webinars, regional webinars scheduled around the state to talk a little bit about PFAS, what the state is doing about it, and what we found in some of your communities. So if we can go to the next slide. And probably should begin by just mentioning that Michigan has a very deliberate approach to address these contaminants of emerging concern called PFAS. We've actually got a very unique multi-agency approach where we've organized 7 state departments responsible for environmental and natural resources protection, agriculture, public health, military installations, fire departments, and commercial airports, all coordinating to make sure that we have the most efficient and effective response to PFAS contamination. We coordinate at all levels of government, including local and federal levels, and as well as work with stakeholders to make sure that this coordinated response leverages all of the resources and keeps us all going in the same direction. And MPART really is the reason Michigan has been so successful at rapidly identifying and reducing exposures to PFAS contamination. And we've taken a very deliberate, data-driven and science-based approach. And I'd also like to recognize that we've got many members of our team here tonight who are available for support if questions come up from the various agencies. And so let's move on to the next slide. And what I'm going to do is just talk a little bit about the compounds and some of the stuff that we're doing in Michigan, and then I'll hand it over to our regional team to explain what they're finding in the communities around you. So what are these compounds? Per and polyfluoroalkyl substances, PFAS. There's over 5,000 of them. We really only focus on a few dozen in all reality. We don't know a lot about all of them. And one thing they do share in common is a really strong carbon-fluorine bond, one of the strongest bonds in chemistry. And they are surfactants, emulsifiers. They like to behave at the space between media, like at the oil-water interface. They repel water and oil and grease. And many of them have been around for quite a while. But one thing that we should note about these is they're not all the same, and they don't all behave the same. So next slide, please. And when we talk about where PFAS are used, it's easier to talk about where they're not used because they are so ubiquitous and broadly used throughout so many industries like, Scotchgard in your clothing, the aqueous film forming foams to fight fires, food packaging. And next slide, please. And that's part of the reason for the concern with these is they are so ubiquitous, they're everywhere, they're so widespread, and we're just now finding the ability to detect them. And one of the things as well, we talked about that carbon-fluorine bond, they're not breaking down naturally in the environment. And so they're really hard to get rid of, even from a treatment perspective. And some of them, and again, not all of these compounds behave in the same way, but some of them accumulate in our bodies. And as Rosa will talk about in a few minutes, some of them have been associated with adverse health effects. And really, we're talking about something we don't have a complete picture for all of these compounds, and really don't have a really strong regulatory structure to address them. So next slide, please. And I like using this because it illustrates the challenge we have as PFAS are being basically cycled throughout our ecosystem because we're not breaking them down or sequestering them. And the landfill is a great example of this. Knowing that PFAS are used in so many consumer products and industrial processes, a lot of those wastes end up in a landfill where the PFAS leach out of those compounds and get into the leachate, which the landfill typically doesn't treat for PFAS, and so they pass on to a wastewater treatment plant that's not designed to treat PFAS compounds. So some of those compounds can end up in our surface water, affecting drinking water sources and the fish that we might consume, and some of them may build up in the wastewater treatment plant sludges, which when they're land applied as biosolids in agricultural fields, they could be affecting the soils, groundwater and surface water runoff, maybe even crops. And so really our challenge is to understand where PFAS are throughout this cycle so that we can break it and protect public health. Next slide, please. And so I'll talk about our three-pronged approach here really to protect Michigan's water. And the first is surface water. And we've integrated testing for PFAS in our surveys of surface waters and fish throughout the state, just like we've done for other persistent compounds like PCBs. And this does a few things. It gives us an idea of what we might find everywhere. And then if we find something higher concentrations, that might help us identify sources so that we can track them down and eliminate those sources of contamination. We've also noticed that foams are generated on surface waters that have been impacted by high concentrations of PFAS, have high concentrations in the foam. It's super concentrated there, and that helps us identify where we might want to start looking further for other sources. And lastly, a really important program is working with our industrial users and our wastewater treatment plants to identify sources of PFAS before it gets to the wastewater treatment plant and gets discharged into our surface water. So we've got a lot of success there, reducing and eliminating those pollutant sources. Next slide, please. And we've gone direct to drinking water and tested and began in 2018 all of our public water supplies. And we've continued to do testing of supplies over the past couple of years, focused on some of the more vulnerable populations like daycares. But basically gone back as well on a few of these where we found some PFAS contamination. And we're doing additional studies there, like quarterly monitoring, just to understand, again, what the occurrence of PFAS are and how it might change, including surface water systems as well, because those might have a better chance to actually have fluctuations. So if you go to the next slide, please. And I just wanted to highlight here for you, this is an oversimplification, but we tested again for only 14 PFAS compounds, but this is under a national method that everybody uses for drinking water. And, 90% of the supplies we've tested over the past several years don't have reportable quantities of PFAS in them. And 7% have something less than 10 parts per trillion total of all those 14 compounds that are listed there. And that's a number where MPART has said that we likely don't need to do anything today at those supplies other than to continue to monitor to make sure that that number doesn't change over time. But 3% are above that 10 parts per trillion threshold, and less than a lifetime health advisory recommendation that EPA uses of 70 parts per trillion for 2 of those compounds. And those are those supplies where we've been going back and doing quarterly monitoring and trying to better understand what's happening and advise those systems to let their customer know what they found and what these results might mean. Start looking for whether or not there's sources in the area that might need to be addressed. Look at options if they need to change their supply or add treatment if the numbers go higher or if additional standards come into play. And definitely start doing more monitoring. And this is also the survey that identified 3 systems that did require an immediate response because they exceeded that lifetime health advisory level for a couple of those compounds. Next slide, please. And so that testing, though, told us that we need to integrate PFAS testing, monitoring, and response into our ongoing water systems and management of them. And typically, we look to the federal government for standards that can be integrated into our rules. And at this point in time, the EPA, it doesn't have a timeline for putting any standards in place. And so we've gone to outside scientists and asked them for their advice. And they've told us a couple of things. Number one, that 70 parts per trillion standard for a couple of those compounds is probably too high given what we know about health effects today. And secondly, we should be looking for additional compounds. And ultimately, we went to a panel that gave us some recommendations for the compounds that we should be regulating. There's enough good peer-reviewed science out there to support defensible standards. And EGLE, this year, successfully promulgated those standards in rule. And the next slide, please. We'll show you here, we have 7 compounds, and a couple of the takeaways I want you to have from this. These are the state's drinking water standards that took effect on August 3rd after going through that rulemaking process. And if you remember, I mentioned that 70 parts per trillion for 2 compounds is probably not low enough. We came out with 8 and 16 parts per trillion individually for PFOA, PFOS. I also mentioned that all these compounds aren't the same. And our scientists told us, and we made it through the rulemaking process, that, yeah, the numbers aren't the same for each one of them because they behave differently. They have different effects on people and how they bioaccumulate. Next slide, please. But I want to also make sure everybody understands that those 7 drinking water standards that apply to those 2,700 public water supplies aren't cleanup criteria. So the cleanup criteria that we have in rules today, where we used to have 70 parts per trillion in rule, have now changed to 8 and 16. That's because of the way our rules are structured. But the other 5 PFAS compounds that were in that table, those will become groundwater cleanup criteria after a rulemaking. And this is important to know for how we define a PFAS site. Next slide, please. So Michigan went from 99 to 138 PFAS sites on August 3rd because that criteria changed. That 70 parts per trillion for 2 of those compounds went to 8 and 16. And even since then, because we are continuing to look for contamination across the state, we've got a very prioritized process focused on areas where we think there might be contamination, and most importantly, whether or not that could migrate and offsite and impact drinking water. And so we're going to continue to add to this group of facilities as we find more contaminated locations across the state. And in all cases, what we will do when we find locations like this is we will do things like this webinar tonight to make sure that you all know what we're finding in your communities and what our next steps are. Today is going to be a real high level review of that. And as we get more engaged in investigations, we may end up having to come back and do community specific webinars, virtual town halls for the current time being, to make sure that we're sharing with you everything that we know and what our next steps are. So next slide, please. And lastly, I'll end with this is, MPART has also established a citizens advisory work group. One of our charges in MPART from the governor is to be transparent and to make sure we're informing our residents. And so our residents can make well-informed decisions. And so we formed a citizens advisory work group, and this is where representatives from impacted communities get together and help advise MPART on two things. Number one, how to better engage and empower communities that are impacted. And secondly, what is the best way for us to put information out there for the general public who may never be part of one of these impacted communities, but to make them aware of PFAS and what the state is doing about it. So at the URL at the end of these presentations, you'll see, go ahead and hit that, and you can go to the MPART page and there find more information under the advisory groups from MPART and basically register. That registration will come to me and we can get you in that group. The group meets every month, Tuesday, the second Tuesday of every month, 6 to 7:30. They've been meeting remotely since they began over a year ago. And we're very appreciative of the work they're doing and looking forward to continuing. So I will stop there now if we go to the next slide and hand it over to Rosa to share with you all a little bit about PFAS and health. Thank you.
Thank you, Steve. So hi everyone, my name is Rosa Jaiman and I am a toxicologist for the Department of Health and Human Services. Over there you can see, can you go again to the other slide, please? Thank you. So over there you can see my contact information. So if you have any question, don't hesitate to send me an email or give me a call. Today I'm going to talk about the role of Ndhs and the local health department. I will also talk about how people can be exposed to this PFAS chemical. I will also going to talk about adverse health effects that have been established for some of these chemicals. Next, please. So the role of Ndhs and the local health department is to understand the health concern that the community is facing. We developed a plan to investigate and address the health risk, in where Eagle leads the site investigation. They are the ones that understand and study how far or the extent of the contamination. And Ndhs and the local health department are the ones that do the planning and response. We also evaluate PFAS response to residents in the community. We also evaluate PFAS exposure to residents in the community, and we recommend public health actions as needed. Next one, please. So how people are exposed to these chemicals? So the general population are exposed to ingestion. And some of the ways that people can be exposed through ingestion is to drinking contaminated water, eating fish caught for water contaminated by PFAS. And when water like river or lake have levels of PFAS, it can bioaccumulate in fish, especially PFAS. And when Ndhs and the local health department know that there are fish that have been contaminated, we issue a do not eat fish advisory for those specific rivers and lakes. Another way that people can be exposed to PFAS is by incidental swallowing of contaminated soil or dust, especially in children, because some of them can have the hand-to-mouth behavior. Also, by using some consumer products or by eating food packaged in material containing PFAS. However, PFAS absorption through the skin is typically not a concern. Next one, please. So talking about exposure, most of the people that live in the United States have been exposed to some levels of PFAS. A study have discovered that most of the people that live in the United States have some levels of PFAS in their blood. Here we can see a survey that the Ndhs did. You can see in this graph that the y-axis represents the average blood PFAS level, and this is in part per billion. And you can see that the x-axis represents the years. The different PFAS that they measured in the blood were PFOS, P4, PFHXS, PFNA. One of the things that we see in this graph is that PFOS and P4 has declined over time. And the reason for this is that since 2002, industries stop or decline the manufacture and use of these two PFAS, PFOS and P4. So we see how PFOS decline around 80% and P4 decline around 30%. So less production and use of those two PFAS cause less exposure of these two PFAS. Therefore, less level of these PFAS in their blood. Next one, please. So there are some adverse health effects that have been established in epidemiological studies and toxicological studies for some of the PFAS. Here in this slide, we can see the adverse health effects that have been established in epidemiological studies, and they are lowering a woman's chance of getting pregnant, increase the chance of high blood pressure in pregnant women, increase the chance of thyroid disease, and especially with P4, increasing cholesterol levels, changing immune response, increasing chance of cancer, especially kidney and testicular cancer. So these effects are supported by studies of different human populations exposed to few or many PFAS, including those populations that were exposed to high levels of PFAS. So more participants in these epidemiological studies who have high levels of PFAS exposure have adverse effects in comparison with those ones that were exposed to low levels of PFAS. However, there are also people that were exposed to high levels of PFAS. However, they didn't show those adverse health effects. Next one, please. So thank you, everyone. And I will let you with Stephanie from Eagle.
Great. Thanks, Rosa. So my name is Stephanie Kamer. I work for Water Resources Division with Eagle. I'm also the MPART Regional Site Lead for the Lansing area. Get back to the slide. And I just want to quickly go through what the regional area is. There's 8 counties that we cover. They line up with our Eagle District Office areas. So Gratiot, Clinton, Eaton, Ingham, Shiawassee, Livingston, Genesee, and Lapeer counties. We do have, this map shows that we do have 11 new sites that we're going to talk about today due to this new criteria. These sites are located in 6 of the counties that we cover. 6 of them are associated with landfill or disposal areas. 4 of them are associated with commercial or industrial applications or processes, either former industrial processes or active ones today. And there's one that's associated with an airport. And so what we're going to do is have each of our project managers who oversee the sites, they're going to go through a kind of a high level overview of each of the sites and give you information with some general next steps. Unfortunately, you know, keeping time in wise, we don't have a lot of time to go through in a lot of detail on each site, but we do want to save time so that there's questions at the end. If you have any questions, you can, you know, use the chat, question and answer box, and we'll try to get to any questions that you may have. And we'll also, each slide at the beginning of the site will have contact information for the presenter. And once we get through all the site reviews, there will be slides that have contact information again, in case you do have specific questions that we weren't able to provide answers for tonight. So with that, I'm going to hand it over to Evan McGuire, who's in our materials management division, and he'll talk to you about one of his 3 sites. This one's in Eaton County that he's going to cover tonight.
Thank you, Stephanie, and thanks to Steve and Rosa for their good introductions. So like Stephanie said, my name is Evan McGuire. I'm the Lansing District Geologist for Materials Management Division at Eagle. I actually have 3 sites I'll be covering today, and Eaton County Landfill is the first site. So before I do get started, I do want to echo Stephanie's sentiment there. You know, this is obviously pretty high level stuff here. We don't have too much time for each site. So if anybody has any questions after this, comments, concerns, please do feel free to reach out and contact me. You know, my phone number's up there, my email. So do reach out. I'm more than happy to sit down one-on-one with anyone who wants to talk and go over specific concerns. So with that, I'll start talking about Eaton County Landfill. I had the address up there on the first slide, but it's here too. This is kind of just a broad locality map showing where it is. It's northwest of the intersection of East Gresham Highway and North Hartel Road in Benton Township. So I don't think this parcel actually has a physical address, so that's just kind of the intersection it's at. And Eaton County Landfill is a closed, what we call Type 2 municipal solid waste landfill or sanitary landfill. So it's just your standard landfill. It wouldn't have taken municipal solid, or it wouldn't have taken hazardous waste or anything like that. It's just a kind of city landfill. It was operated by Eaton County from 1971 to around 1982 when it closed. So back during that time, there's a lot of kind of environmental legislation that was being passed, and back then it was the DNR that was trying to get some of these old city dumps and landfills in some kind of environmental compliance. So a lot of them just ended up closing, and that's what happened with Eaton County Landfill. And the reason it was targeted for PFAS in our investigations was, you'll see with a lot of these sites, it has known historical contamination of groundwater. So we've known about this since the 1980s, and it led Eagle to request PFAS sampling. So this historical contamination in this site was related to a group of chemicals we call volatile organic compounds, or VOCs. And that's true for a lot of landfills that have contamination. And so next slide. So here's a more detailed kind of locality map. In this map is a typical site map for these kind of sites. It has the monitor wells we sampled, the groundwater flow direction, the property and surrounding areas. So we asked Eaton County to sample this in 2019, and they agreed. And the sampling event took place in August 2019. And as a result of that, we found that one of the monitor wells we asked them to sample did have PFAS concentrations over the current cleanup criteria. So in monitor well 15S, it's the shallow, it's seated in a very shallow, like uppermost aquifer, had a PFOA concentration of 27 parts per trillion, which exceeds the 8 parts per trillion cleanup criteria for that compound. So it was just the one compound PFOA that we had over criteria. And like I said, monitor well 15S is seated in this shallow glacial aquifer. It's kind of above any of the drinking water aquifers in this area. And the groundwater flows to the northwest. So you can see that arrow there pointing to the northwest. So just like surface water flows downhill, groundwater flows too. We don't call it downhill though, we call it down gradient. So groundwater flows down gradient, and that's important to know because any contamination in that groundwater is going to flow with that down gradient flow of the groundwater. So the good thing with this site is that we do have, because of that historical contamination, we do have previous hydrogeological investigations that really did a good job characterizing the geology and the groundwater in the area. So we already had this monitor well infrastructure to look at this contamination of PFAS. The PFAS is part of the same, we call contamination plume that I have labeled on there. It was a historical contamination. So as a result of those previous investigations, we know that the contaminant plume hasn't really migrated very far down gradient. So they installed a group of monitor wells down gradient, and those have been testing clean for years for the VOCs. And when we sampled them for PFAS, they tested clean too. So that's good to know. It shows that the contamination is really kind of restricted to the area just immediately adjacent to the landfill. And there aren't residential drinking water wells in that area. So we think at this point it's very unlikely that residential drinking water wells are impacted. We did a fairly comprehensive search for drinking water receptors in the area, and we found they're seated deeper than the contaminated aquifer, and there's a rather large separation distance. So that's encouraging. In terms of next steps, we do have to take some next steps with this site. Just if there is contamination, it's not an immediate concern for residential drinking water, but does have to be addressed. So the first step is to basically just resample and confirm our results. We've only had one sampling event so far, so we do need to confirm those initial results. And so this was sampled in 2019. In PFAS time, that's kind of ancient history. So the laboratory reporting limits at that point for some labs were higher than they are now because the cleanup criteria was higher. It was 70 parts per trillion, and now we have 8. So we need to retest with that lower detection limit to ensure that our non-detects in those other wells are true non-detects. And depending on the outcome of that, we might have to add PFAS to a routine monitoring program as part of the landfill's groundwater monitoring program. So that's all I had for Eaton County Landfill. So the next site is Lockhart Chemical Company, and David Lebrecht will be talking about that. So I'll pass it on to him.
Okay. Alrighty. I'm not sure if I'm on here, if everybody can hear me.
Yes, we can hear you, Dave.
Alrighty, sounds good. We are getting started here with the 2 City of Flint sites. I'm covering for Paul Buchholz is the project manager, the site lead. His contact information will also be included at the end of the presentation. I am covering for Paul in his absence. I'm the district supervisor for the Remediation and Redevelopment Division in the Lansing District Office. And the first site we're going to go over is the Lockhart Chemical Company. And we can go to the next slide. So Lockhart Chemical is an ongoing active site. The site was identified for PFAS sampling in part with combination of a Water Resources Division's investigation of an adjacent storm sewer, along with historic or detections of PFAS detections within the Flint River. Groundwater flow is to the east to the Flint River there. It can be seen to the right of the slide, to the east of the site there. And so with the emerging contaminants and looking at potential sources contributing to the Flint River, PFAS was included into the sample analysis for Lockhart Chemical. Previous evaluations of residential wells exposures, looking at potential receptors, have identified a little potential for risk exposure through drinking water wells. Like I said, it's within the city limits of Flint. There are some wells that have been identified further to the east and northeast of the site. And based on other groundwater investigations in the area, there's a pretty confident or pretty good understanding of groundwater flow to the east and southeast towards the river there. And so that's kind of what the basis was based upon. Can we go to the next slide? So this is an aerial photograph depicting the site, shows a little more detailed view of where the site is at. So going forward, Eagle staff will continue to work with the local health department just to verify and confirm potential well receptors in the area. And we'll look at those again to just confirm, based on the information we have here, that similar to other sites, it doesn't appear to be presenting a risk to area drinking water wells. And ongoing with that, we'll continue to work with the potential responsible parties with ongoing investigations to determine the nature and extent of the release and releases from the site, and kind of move forward with that, with those actions to mitigate any of those other risks. We can go to the next site. Next site is the Racer Hemp Hill Road Industrial Landfill. Location there is noted at the southeast corner of Saginaw and Hemp Hill Road in Brighton. So this is just on the outskirts of the city of Flint, so adjacent to the Brighton Township. And so Paul's site here was identified. We have an ongoing investigation with the private party who was doing work pursuing what was called a no further action report, doing ongoing investigations. Again, with the emerging contaminants of PFAS, those were included in a subset of monitoring wells at the location, and were that an analysis resulted in the detections of PFAS constituents there. Shallow groundwater flow is to the east towards Shram Drain. There are some drinking water wells located some distance to the east of Shram Drain. But again, similar to the other sites, we've looked at the wells with the health department and looked at well construction and the depth of the wells where they're drawing the water from. And initial evaluation of those does not look like they pose a drinking water risk. We can go to the next slide. So this is a depiction of the Hemp Hill Road Industrial Landfill. It's the kind of brownish or tan shaded parcel on the left side of the figure there. The green parcel to the east was a former municipal or township dump, and the line dashed line out there depicts the extents of estimates of waste fill, and so again, this is an active site that we're working with the health department. We'll look at potential receptors in the area with the local health department, confirm that there's no potential risk to drinking water wells, and then continue to work with the potentially responsible parties to continue to pursue the no further action report for that site. And that's all I have for that. I'll turn it over to Sean Shields for the next site.
Hello, I'm Sean Shields. I work in the Materials Management Division of Eagle, and I'm the Eagle site contact for PFAS at the Racer Flint West site. My contact information is available on this slide and at the end of the presentation as well. Next slide, please. So Racer Flint West is a 3-acre property at the northwest corner of Glenwood Avenue and Stevenson Street in the city of Flint. Presently, the property is undergoing site investigation, remediation, and redevelopment activities through Racer Trust. But historically, the site was once part of the larger Chevrolet, then GM and Delphi manufacturing plant. And the site itself included a variety of manufacturing operations, including chrome plating. The Racer Flint West site was targeted for PFAS sampling in large part due to the historic use of PFAS in chrome plating operations, which were known to occur at the site. So subsequent sampling from the on-site groundwater monitoring wells has identified PFAS contamination in the shallow groundwater at concentrations above the new Part 201 drinking water groundwater cleanup criteria. And so presently, Eagle is working to evaluate any off-site exposure pathways to the PFAS contamination, and the facility MPART webpage will be updated to reflect progress and new information as the site investigation progresses. Next slide, please. So to get into a little bit more detail, at the Racer Flint West site, the shallow groundwater is encountered around 10 to 13 feet below ground surface, and the groundwater flows generally to the northwest towards the Flint River. PFAS sampling of the shallow groundwater has identified PFOS as the primary PFAS compound, with concentrations ranging from non-detect to 93 parts per trillion. The PFAS compound PFOA was also observed at the site, concentrations ranging from non-detect to 12 parts per trillion. Other PFAS compounds such as PFBS have also been identified in the on-site groundwater, but the concentrations observed did not exceed the new drinking water MCLs. So as part of the next steps that we're looking at for the site, additional groundwater monitoring for PFAS is planned. In addition to that, we will be looking at sampling stormwater and potentially the Flint River near the site to sort of help evaluate the extent of PFAS migration to and into the Flint River. So data from these future sampling events will be incorporated into the facility MPART webpage as the data becomes available. And so at this point, I'd like to hand it over to Kim to go over another MPART site.
Hi, my name is Kim Sikowski, and I am in the Lansing District Office as a project manager, and I am overseeing the Kent Cleaners project. And as you can see, here's my contact information if you have any questions about the site, and it will be again repeated at the end of the presentation. Next slide. So the Kent Cleaners property, it's located on the southernish side of Lansing, right on the corner of South Washington and Dunlap. We began looking at the site as simply a dry cleaner site. We were concerned about potential vapor migration into the surrounding neighborhood. And again, we were focused on the chlorinated compounds. And throughout doing that work, we found some anecdotal information that the dry cleaner performed waterproofing as one of the services. So that led us to sample the groundwater for PFAS. And we did have a hit of PFOA during that first round of sampling in 2018. Because this is in Lansing, right downtown, everybody was on municipal water, so we did not have a threat to drinking water wells in the area. Next slide. And again, being in Lansing, groundwater is fairly deep here. It's around 35 feet. And this is an area that's a mixed residential and commercial area. Groundwater is generally flowing to the east, northeast. We initially sampled the site in 2018. Then we focused on the cleanup of the property for the chlorinateds. So the site was just recently sampled again in 2020. And we found that, oh, sorry about that, my phone just went off. We found that the chlorinateds had cleaned up, but we really didn't change much from the PFAS samples that we had, the concentrations we had before. So our highest detection of PFOS was 13 part per trillion. And then in the second round of sampling, we also detected PFOA at 20 part per million. So we don't have a direct receptor here, but we've added PFAS sampling to our confirmation sampling from the cleanup, and we'll just continue to monitor for the next several years just to see, if we see any changes and, to determine if any additional steps will be needed. Next slide. Eric Martinson is up next.
Thank you, Kim. Yes, so my name is Eric Martinson, and I work in the Superfund section in the Lansing district. My site here is the Metamora Superfund site located at 1811 Dryden Road in Metamora Township, Lapeer County. Next slide, please. So, as you can see here, there's the location of the Metamora Landfill Superfund site. The PFAS work plan was worked on in the fall of 2019 and then approved in January of 2020. In April of 2020, the contractor collected samples, PFAS samples from the site. 18 monitoring wells were selected to get a representative sample of the site conditions. 3 of those samples that were collected exceeded PFOA criteria of 8 parts per trillion. Those samples ranged from 8.2 to 13 parts per trillion, and the highest concentration was encountered in a monitoring well in the center of the landfill. Next slide, please. All of the, as I said, the 3 locations that were collected, that were had exceedances for PFAS were located in the shallow aquifer or zone of groundwater. The map on this slide shows each monitoring well that encountered or was sampled that ended up having a PFAS detection. So these aren't exactly exceeding criteria. So as I said, there's 3 aquifers present at the site or zones of groundwater. There's a shallow, intermediate, and a bedrock aquifer. Groundwater flow in the shallow aquifer is predominantly north as it makes its way through the landfill, and then there is a northeasterly component as it leaves the landfill. In the intermediate zone, there is a northerly flow with a radial component to the north where the groundwater flows in each direction. And then in the bedrock, we're seeing a predominant northerly flow. Currently, there's approximately 30 residents that are down gradient of the landfill. Currently, Eagle is working with the Lapeer County Health Department to formalize a plan for next steps. Right now, we're hoping to collect a select group of samples from residents that are located in the bedrock zone, as that is where those residential wells are screened. Next slide, please. And Rebecca Taylor will talk about the next site.
Hello, my name is Rebecca Taylor. I'm with the Lansing District Office, Eagle, Remediation Redevelopment sites. So coming up next is our 3 sites in Livingston County that recently became MPART sites due to either a new discovery of PFAS or PFAS that is presently above the current criteria. So my contact information is on the screen. It's at the end of the program. If you have any questions beyond the this presentation, please contact me and I'll do my best to answer them for you. Next slide, please. This site is, the new site is 1279 Rickett Road, also known as March Coatings. It's in Brighton, Livingston County. Next slide. Could the slides be advanced, please? Hello, anybody there? Sorry for the technical difficulties.
Sorry, my slide is advancing. Is it not showing?
It's not showing. Sorry.
Okay. Let's see.
Hey, Stephanie, you may just have to reshare your screen again. So stop
Okay.
sharing and reshare maybe. We can see your screen now.
Okay. Can you see that? I'm sorry. I'm
It
not
says
sure.
site leads contact information. That's what we're seeing right now.
Okay. We'll get you going here again.
Yeah, keep going. There we go. Stop. Perfect.
Okay.
This facility is in Brighton. It's within the municipal drinking water system, at least where the property is located. However, south of the property, there are residential wells. So this particular property recently came to light when what we call a baseline environmental assessment, which is basically all appropriate inquiry done through commercial property transactions to evaluate the environmental condition of the property. So we received information that PFAS was detected in the groundwater less than a month ago. So the previous manufacturers engaged in various fluid coupling, fabrication, engineering, metal coating, and finishing operations for a period of about 15 years until recent closure of the last March Coatings property. It's now going to be an office building. So baseline environment assessment was received and PFAS results were portrayed in that submittal, which resulted in this property becoming an MPART site. Next slide. So apologizing for the graphic, which is doesn't show up very well. One of the issues with this particular graphic is that if you were to blow it up and you saw the units for the PFAS, they're reported in parts per billion, and the criteria are in parts per trillion, which is 3 orders of magnitude different. Where are we going here? But in 4 groundwater samples were collected, shallow groundwater samples. The highest PFOS and PFAS contamination were located near the material storage area in the shallow groundwater. So PFOS was at 2,900 parts per trillion. On this graphic, it's reported at 2.9 parts per billion. So there is a unit discrepancy here. It will be corrected later on. And 130 parts per trillion PFOA, which is over the old criteria and certainly over the new criteria, but this is a brand new, this site just recently came to light. So because it was a baseline environmental assessment, there's very little information with regard to the distribution of the contaminants, where the contamination is going. There's only temporary wells set. So all we know is that it's there in the shallow groundwater. There's no groundwater flow information. And all we can do is sort of draw a radius around the site and look for where residential wells are. So right now we're in the process of identifying residential wells which may be in the path of potential groundwater flow. So when we do that, we can sample these wells and determine if there's anything that has migrated off this property that's going in a southerly direction, basically. So that's where we are with that site. Next site is also in Livingston County's Brighton Township dump. It's It's outside of Brighton city limits to the northeast. It's in near Corlett Drive. It's actually, it would be to the west of the GM Proving Grounds. It's a country estate rural area. So next slide, please. So this dump accepted waste in the 1960s and early 70s. And it has a history of cleanup actions back in the early 70s. The dump closed, and then EPA and Eagle removed drums and waste disposed in ravine and wetlands. And as a result of the state-funded actions, the local unit of government entered into a consent decree to pay for some of the past costs and do work regarding site evaluation work with the landfill, and in that process of the consent decree, they sampled surrounding residential wells for volatile organic compounds. None were detected in any of the surrounding residential wells, but because PFAS is an emerging contaminant, that was not sampled for. And so what happened in May of 2020, when the consultant for the private party under the consent decree collected a limited number of groundwater samples from monitoring wells in the southeast corner of the property, Eagle collected split samples from those 5 monitoring wells to see if PFAS was present. The time frame for waste disposal corresponds with when PFAS was prevalent in manufactured products that were put in municipal landfills. That's why we sampled for PFAS. So PFAS was detected in 3 of the 5 monitoring wells above the current criteria. Next slide. So this is a rather dark slide, but if you look closely, you'll see some blue arrows moving to the northwest. And because this is under consent decree, it has had some groundwater work done. So there's some information about groundwater flow that's known, and so we're in a better position to evaluate risk to residential wells because we do have some information. And the deeper groundwater flow does tend to go to the northwest. There are residences with wells in that direction. And shallow groundwater flow, where we sampled the wells for PFAS in the southeast corner, that's near the wetlands, and the contaminants are traveling in an easterly direction, which suggests that there's a slight groundwater divide seasonally, that contamination can flow to a different direction than the prevailing northwest groundwater flow direction. So the wells that are surrounding the landfill will draw water from the sand layer that are below clay layers where the contamination was discovered. And there are about 10 residential wells surrounding the landfill. And as I said before, they were sampled for volatile organic compounds. Nothing was detected. PFAS travels slightly differently in the environment, so it's going to be sampled for in residential wells. But before we do that, we have not sampled a whole lot of monitoring wells on this landfill for PFAS. So within the next couple of weeks or so, PFAS will be sampled in a number of monitoring wells at the landfill, and then the residential wells that appear to be most at risk, we'll contact them for sampling at a later date. So it'll be part of a survey process and looking at which wells are most at risk and getting access to collect samples from those wells. So it's in progress right now, but the first immediate step is to find out the nature of the beast, so to speak, in more monitoring wells within the landfill itself. Presently, there is a deed restriction on the landfill, so there's no use of groundwater at the landfill. Next slide. Hey, this is my last slide. This is an airport, Livingston County Airport, also known as Spencer Hardy Airport. It's in Howell. It's a non-commercial flight airport. And it's basically near where M59 and Grand River come together, Grand River Drive come together on the west side of Howell. That's where it's located. Next slide. That's a location map. So what happened is way back in 2018, a small jet crashed in a field beyond the runway, skipped over the fence, and landed on Livingston County Airport property. The pilot was rescued immediately, and then the fire department came and put out the fire. So airports require a FFF foam be used to suppress fires, so that's what was used to suppress the fire. And after that was done and evaluation work was performed under insurance policy, 540 cubic yards of contaminated jet fuel soils and were removed, and 6,650 gallons of contaminated groundwater, mainly related to the jet fuel, were pumped out and lawfully disposed. So PFAS that may have been entrained in that media is now gone. But shallow groundwater was sampled at the time after it was discovered that the fire department did indeed use PFAS containing foam. And at the time, criteria was not exceeded. Next slide. So this diagram pretty much shows in the little yellow box and the little red loop where the spill was. And the arrow shows is going in the general direction of the Shiawassee River. And there's one residence that has a well that's presently not occupied. And so for the samples that were done from temporary wells, where some groundwater flow direction was found, that only 2 of the 14 temporary wells exceeded current criteria for PFAS. Basically, it's PFOA that exceeds the criteria, not PFOS. And groundwater flow goes easterly towards the north branch of the Shiawassee River, which is less than a quarter mile away. And then that arrow goes to the house that shows the general direction of groundwater flow. It's a little bit outside the path of the flow. And the area where the spill happened seems to be quite localized. The shallow groundwater is only about 8 feet deep. And so there is that one well that will need to be evaluated. So the airport has been contacted regarding the fact that where they thought they didn't have an issue previously with PFAS, and we did warn them that the criteria may be going down, so they kept the insurance claim open. And so Eagle will be asking the airport to voluntarily perform additional evaluation work regarding whether or not PFAS is even still present in the groundwater. And if it is, to evaluate at least the residential well that's closest to it to see if there's an exposure related to that release. So that's where we are with that site right now. And in the future, this may get closed out as an MPART site, but right now we'll have to wait on the information. So into the next speaker, please. And this would be Evan.
Thanks, Rebecca. Can you hear me?
Yes, we can hear you.
Yes, we can.
Okay, good. I apologize, I'm a little frazzled. My power just went out and sitting here in the dark, and I had to connect on my cell phone at the last minute. So bear with me here. I don't have video. So yeah, Livingston County Landfill. It's another landfill similar to Eaton County Landfill. It's located northwest of East Barron and Fisher Roads, and it's in Howell Township. So next slide. So again, here's the high-level locality map showing where it is. So again, it's a closed type 2 municipal solid waste landfill, which is owned and operated by Livingston County. And again, it was operated from the early 70s into the 80s before it closed. It's about 3 miles north of Howell in Howell Township, to give you a better idea. And again, like Eaton County Landfill, It was targeted for PFAS sampling because of known historical contamination, the same group of chemicals, the volatile organics. This is a landfill that we get routine semi-annual monitoring reports from, so that's good. We have a lot of data, groundwater data to go off with this site. So next slide. Thank you. All right, here is the more detailed locality map showing the landfill, the groundwater flow direction, and sampled wells. So we asked Livingston County to sample last year, and the sampling event took place in May 2019. And again, we found PFOA in one monitoring well that was slightly above our cleanup criteria. So monitor well 4S had a PFOA concentration of 9 parts per trillion, which exceeded our cleanup criteria of 8 by 1 part per trillion. So it's really low level contamination, but the concern here was the proximity of residential wells. There had been impacts in residential wells from historical known contamination too. So that was our concern. And even though at the time, the 9 parts per trillion wasn't above the cleanup criteria, the drinking water criteria, Livingston County was very proactive in their sampling, and they did jump out right away and sample 14 residential wells. And they found that none of those wells were above our drinking water criteria, but one did have PFAS compound detections. They're very, very low level, below any of our drinking water MCLs, and the compounds that were detected were actually not even regulated. One of those residential wells did have detections, like I said, but luckily that well was already being, that home was already being provided drinking water by Livingston County because of the previous contamination. So that house and a couple other ones, Livingston County had been providing drinking water. So you can see on the map there, the groundwater flows to the northeast, and I've kind of outlined where the plume, the contamination plume is there, just around monitor well 4S. So anything in red in that plume would be where we would expect the groundwater is above our Part 201 cleanup criteria. So the next steps with this site will be continuing residential well sampling. So the county does yearly residential well sampling, and they're going to do 15 wells this year. And because we found PFAS, they're going to add PFAS to the residential well sampling plan. So sampling 15 wells should come up here in the end of September. And with that, we do need to resample some of the monitor wells again to, confirm our results and make sure that we have the contamination delineated. So that's all I have for Livingston County Landfill. And the next site is another one of my sites. Also, Venice Park Recycling and Disposal Facility. It's located at 9536 East Lennon Road in Venice Township, Shiawassee County. And again, my contact information is there. Next slide. So here's the broad locality map. Venice Park Recycling and Disposal Facility is our active type 2 landfill. So it is still currently receiving waste. It's a large landfill located in Venice Township. It's about 2 miles west of the town of Lennon, if that gives you a better idea. It is owned and operated by Waste Management, and it has been since 1991 when they purchased the landfill. And just like our other sites, we targeted this one because of known historical contamination. And because it is an active landfill, Eagle does get quarterly monitoring reports, groundwater monitoring reports from this facility. So again, we have a lot of data associated with this, and we have a fairly good understanding of the geology and the hydrogeology. Next slide. So here is the more detailed location map showing the landfill, groundwater flow direction, and the wells we sampled. I have call-out boxes on here showing the concentrations of PFAS we found. So again, the concern here was historical contamination, and on this site, the wells we were most concerned about are along the west side of the landfill. We have we sampled 2 there, KW15 and MW21SR. And the concern there was that was where the historical contamination was, on that west side. And at the time, the concern was the groundwater is flowing to the west, the southwest, and there's a large neighborhood with a lot of residential wells on there just off Durand Road. So that was our concern this time too. And we added a couple other monitor wells to sample. So during their investigation of the historical contamination, they found that those residential wells to the west were not contaminated with the previous contamination. So again, it was volatile organic chemicals they were looking for. And the geology of the area is such that there's kind of substantial clay layer that acts as a protection from the contamination for the drinking waters, which are seated in deeper aquifers. So we asked Waste Management again in 2019 to sample select groundwater monitoring wells, and they did in November 2019. And again, we found one monitor well that had PFOA again, that was above our new cleanup criteria. So I have monitor well 34S there highlighted on the south, and we found 17 parts per trillion PFOA there. And that again exceeds the criteria of 8 parts per trillion. So the geology of the site is a little bit more complex than other sites. There's actually 2 aquifers that are monitored by the facility. There's a shallow, what we call channel fill aquifer, and that's where the contamination was found. It's a fairly laterally restricted aquifer, so you can see the outline in orange there. It's basically the remnants of an old glacial river system. So there's sand and gravel in there that acts as a good aquifer. That's where our contamination was. There's one that the facility monitors that's slightly deeper. We call the outwash aquifer. And below that, again, there's substantial clay layers. And all the residential wells that we investigated in the area down gradient are seated below those clay layers. Most of them are in the bedrock, actually, below any of the glacial sediments. So we don't think residential wells are impacted at this time. We do have a pretty good understanding of the geology and where the contamination is moving. So that's good. The next steps with this site are, again, like the other sites, we need to resample our monitor wells to confirm our results. And then we need to work with Waste Management to come up with a plan to more fully delineate the contamination. So you can see on that plume there, I have a little question mark because we don't have any down gradient wells installed right now. So that plume, the southern extent of it, we don't know exactly where it goes. We can estimate that it probably won't go too far because of the low concentrations. As groundwater contamination migrates from the source, the concentration gets lower and lower. So it probably doesn't go too far, but we do need to delineate the whole extent of that plume, both laterally and vertically. So that's all I have for Venice Park. I'll hand it back to Stephanie here.
All right, thank you, Evan. And thanks for rejoining us so quickly. I was a little worried there for a few minutes that we were gonna.
Yeah, that was something out of a nightmare there when the power cut out and my screen blacked.
But it worked out well, so thank you. And thanks to the other site leads. This is the contact information for the site leads for those sites that were just covered. I'll leave this up here for another minute if you want to, write it down. If you're interested in following up with them for questions, we are available. The webinar is supposed to go to 7:30 to answer questions right now also. But if you want to follow up later, take a picture or write down the contact information. These are the best guys to talk to about if you have questions on individual sites. And then the next slide is contact information for our local health departments associated with the counties where the sites are located. And so if you have questions on public health and how these sites could be impacting your health, here's contact information for those health departments. And I'll leave this up here for a minute. Okay, and with that, I am going to turn it back to Les for any questions.
All right, thank you, Stephanie, and thank you to all of the presenters this evening for covering the new sites under MPART. I just want to remind all of our attendees that if you have questions for any of the panelists or just about or anything about PFAS in general, please utilize the question and answer box located at the bottom of your screen in the Zoom webinar here. And you also have the opportunity to raise your hand and we will see that. For our listeners that are on the phone, we did have a few earlier. You can press *9 to raise your hand electronically and we'll acknowledge you and unmute your mic. We do have a few questions that have come in that were written into us, and I will start with the first one. We have a question for, this deals with municipal water supply hookup. I have a home in an area with city water access, but prior owners decided they liked well water. Does Eagle collaborate to help those not connected to municipal supplies get connected to city water?
Well, I'll start and then ask the rest of the team here if they've got additional information. I think the first question is, at least from the perspective of PFAS and what we do in MPART, is question is whether or not you actually have contamination, and if you're part of an active investigation area. When you say collaborate, we do look to see that everybody who is within a municipal system is hooked up. And in many cases, we found that that's not always true. And so we do test those wells to see if there is contamination due to a source we're investigating. And if we find that contamination, work with our public health professionals to make recommendations to the resident, whether it is to go on alternate water or hook up to a municipal supply longer term. I think more generally, if perhaps Rebecca or someone from the Part 201 program can talk about what resources the state may have for other contamination purposes and how that program might work.
I'll try to answer this question in a general way. At least in the area I work with, Livingston County Health Department, what they do under contract from Eagle is that for contamination sites in general, we'll have a contract to investigate wells that are in risk of contamination. So samples for non-PFAS compounds are collected by the county. So for PFAS sites, it's a separate issue, and different residential wells may be sampled, or the same residential wells that the county samples may be sampled for PFAS that had previously been sampled for other compounds such as volatile organics or metals or nitrates or whatever. So it largely depends, as Steve said, as whether or not the particular well in question is within a contamination investigation area. So the local health department may have information, if you're not in a contamination investigation area, as to what the process is for connecting into the municipal water supply. And it does cost money to do it, and I don't know if individual health departments have grant money available or anything like that. Usually people end up connecting on their own dime if it's not a matter of contamination from another source.
Okay, thank you, Rebecca, for your answer. Next question. One of our attendees would like to know where on the web can we find a copy of this evening's presentations? Steve, I would imagine that the presentations tonight will be placed on the MPART website.
Yeah, yes, and in fact, I'm not sure exactly where, but the idea is that the recordings of these and the actual presentation slides, a PDF of those will be posted. And I would go to the MPART website and look for that.
Okay, thank you, Steve. And I think we have a slide coming up that has that information for how to access the MPART website. And there it is.
Yep, that URL will get you to everything that the state has related to what we've been doing in MPART, from including the site information that folks here talked about tonight. All those write-ups and all the updates will be made available there too. And they're already posted, anything that was talked about tonight.
Okay. We still have some time left this evening. If you have a question out there related to anything you heard this evening, Steve, do you have anything, or any of the other panelists have anything that they would like to add that they may have missed during their discussions with us today?
Well, I'll just add again my appreciation to all the panelists today, and then all of the rest of the MPART team, who've been hanging out in the background to support any questions that might come up tonight. And then thank everybody, there who's attending, for your participation. We had a lot to go through tonight, and as our team has said, we may, do additional virtual town halls as we get more information and need to expand our investigations to make sure that everybody's informed about what we know and what our next steps might be. And most importantly, please don't hesitate to reach out to any of us, and you can go to the webpage there as well and get additional contact information. We'd be more than happy to answer any questions you may have. And so, and Les and Jim, thanks very much for running the show here tonight, and Stephanie for advancing the slides.
You're welcome. Now, Steve, I had a question for you. Question is, how does the lack of an EPA standard, how does it affect the work that we do?
Well, I think initially it made it a little bit more difficult for us because we didn't have a standard when we did all that first public water system surveys. And so we were basically giving recommendations to water systems, and, and that based on that 70 parts per trillion. And, we were doing the monitoring. The state did all of the monitoring, and it was one data point. Whereas if you had EPA standards, then the systems would be doing that monitoring themselves on a regular basis, and it would be an enforceable requirement for water systems to actually implement whatever remediation measures might be needed, like treatment or different supplies. Now, fortunately, Michigan has succeeded in adopting 7 Pfas drinking water standards. And so the lack of a federal standard for drinking water now isn't impacting us like it is other states who aren't fortunate to have their own standards.
All right, well, thank you, Steve.
Yeah.
We were at 7 minutes to 7:30. I have no new questions for you. Yes, I have no new questions for you. Again, if attendees, if you have questions, you have the contact information for tonight's presenters. The michigan.gov PFAS response website is on the screen there if you'd like to take a picture of that. Stephanie, if you wouldn't mind going back a couple of slides so we can capture the tonight's presenters again. Yes. So if you want another opportunity to take a picture of that with your phone, these are the folks that are the leads for each of the sites that you heard this evening. And I'm sure they'll all be happy to share what they know with you. With that, I'm not seeing any new questions. So I, again, like to thank you all for coming to spend the evening with us. We won't belabor the time. Again, please keep an eye out for the recording for this webinar, which will be posted on the MPART site. The recording for the Lansing, for the Kalamazoo and Jackson meeting is also available now from last night's meeting. So you can visit the Eagle YouTube channel and check out the MPART page for that video as well. And with that, I want to thank you all for your time. Have a wonderful evening. And this concludes today's webinar. Thank you.